Hey everybody, welcome to this video. I want to talk about some of the ways that I'm going to teach your kids about math. If you're a teacher watching this, hopefully you can see the progressions and think what I'm thinking. If you're a parent, hopefully this can explain a little bit more. If you're a student, hopefully you can understand this as well. This is where we take a look at multiplication from a 4th grade level. This is standard 4.NBT, that's numbers in base 10. I think it's number 5. It might be 4. I'm gonna have to check this. But what I want you to do before we start is I want you to take a number like 319 and we're gonna multiply that by 8. Okay, my question is, how do you go about solving a problem like that? And if you're like me and you remember back when you were in 4th grade, for me that was about 26 years ago, what I remember being taught what to do is you take 8 times 9, which is 72, and you put your 7 up here, and you take your 8 times 1 and you add 7, and so you get 15, and you put your 1 up here, and you get 8 times 3 and you add your 1, that's 25, and you'd get the answer 2,552. Right? You're showing a series of steps. It's very procedural. And so yeah, we call this the standard method, right? You'll also hear it referred to as a traditional algorithm. And this is fine, right? This is a way to multiply 319 times 8 to get to 2,552. It's accurate, it's efficient, it works. And I tell my kids that when they learn multiplication, it's kind of like telling them a story. And to be very honest, this is the end of the story. So what I wanted to do is I wanted to take a few minutes today and I want to talk to you a little bit about what that story exactly is. Okay, now hopefully the kids are coming to 4th grade with some understanding of basic place value, and with some math fact recall. So I'm going to assume a few things here. I'm going to assume that your kids can skip count by tens, hundreds, thousands. I'm going to assume that your kids know all their math facts. I know that's not true, but for the purpose of this video, that's exactly what we're going to do. Okay, so what I want to do first is talk a little bit about multiplying just pretty easy numbers. This is multiplying by tens, hundreds, thousands. So if you take 4 times 10, most of the kids are going to be able to skip count by tens, right? And I'm going to draw some. These are, if we call them base 10 blocks. That's going to represent 10. And when we use them in class, they're about this long, and then they're cut into little sections, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they can literally count 10, but I'll just draw them quickly like these last 3. So we count these up, and we've got 10, then 20, then 30, then 40. 4 tens is 40. We'll do something like 6 times 100, and then we have, these are flats. It's not totally proportional, but for the purpose of this video, we're just going to call that 100, and those are split up 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're going to look like this, and then we have 100, 200, 300, 400, 500, 600. So all the way to 600. 6 times 100 is going to be 600. And then we'll take something like 1,000 times 5, and we've got cubes. Now I only have one of these in my classroom right now, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. And if you literally took this apart, you would count 1,000 cubes, but just for all intents and purposes, we'll just say 5,000, 1,200, 1,000, 2,000, 3,000, 4,000, 5,000. So this would be 5,000 there, okay? So I'm gonna assume that that's a pretty quick lesson, being able to multiply by tens, hundreds, thousands. That's super important for this concept. The next step now is being able to take something like, we'll say 3 times, not 10, but a multiple of 10, right? And I look at that as an adult and I say, well, it's 60. And you could say 20, 40, 60, that works. You could go 10, 20, 30, 40, 50, 60. But what we're gonna do here is we're gonna take a look at what this is and how it relates to what we had previously learned. So we're taking 3 and we're gonna think about 20. And 20 is 2 times 10. Now by this point of the year, your child's done a whole lot of work with base 10. So multiplying and making things 10, 100,000 times bigger, it's a lot easier. We've done so much practice with that. So now we're going to take 3 times 2, and we get 6, and we regroup this. We have 6 times 10, and 6 times 10 is going to equal 60. The idea here is, again, factoring this out so we can multiply by 10, 100, 1,000. I'll show you another example here. We take something like, let's say 600 times 4. I look at that and say, oh, 6 times 4 is 24. With 2 zeros here, I get 2400. But let's think about what that really means. We got 600 is 100 times 6, and then the other part is times 4. All right, now we'll combine that. 6 times 4 is 24, and we're making that 100 times bigger. So we have 24 times 100, or as I show the kids, we've got 24. And then we're going to make it 10 times bigger, 100 times bigger. Okay, so by being able to multiply by 10, 100, 1,000, that's the first step. Now multiples of 10, 100, I don't have 1,000 in this example, but that's the next step. All right, so after we cover those basics, the next thing I want to show the kids is how to break these numbers apart. So if we have 200, let's say 213 times 5, we've also done a ton of work with what's called expanded form, where you take these numbers apart and you basically expand them so that 2 is worth 200, and that 1 is in the tens place, it's worth 10, and the 3 is in the ones place, so it's worth 1. So we've got 200 times 10 times 3. And so we can break these numbers apart, and we're going to be able to multiply those out. So we'll do 200 times 5, and we'll do 10 times 5, and we'll do 3 times 5. These numbers have been broken apart, so we can each multiply those parts. Now, if you want to see 213 5 times, I'll draw that quickly. There's our hundreds. There's 10, 1, 2, 3. So there's 213 in base 10 blocks. We're going to draw 5 of those. 10, 11, 12, 13, 100, 200, 300, or 210, 11, 12, 13, 100, 200, 10, 11, 12, 13, 100, 200, 10, 11, 12, 13. So now we can look at this and remember that these are all hundreds. So we'll count 100, 100, 200, 3, 4, 5, 6, 7, 8, 9, 10 hundreds, or 1,000. Remember we've done 2 times 5 is 10, and we get 10 100 times bigger. Okay, so one part is 1,000. And now we're going to count our tens. We got 5 tens, which you'll remember that we've already worked on multiplying by tens. And for this also, we've worked on these. These are skills that are getting mastered. So we've got 10 times 5, which the kids will know is 50. And then we've got a 3 by 5 array here. So 3 times 5 is 15. We broke this number apart, and now to figure out the total, we're just going to add them together. And each of these parts is a product over here, and they are parts. So you might refer to this as being called partial products. What I don't want you to do yet is I don't want you to skip to that, because the idea here is, what does this look like as an array? Okay, if we can build this and we can see it and we know how much it is, now we're not just being taught, as I mentioned at the beginning, now we're not just being taught a procedural step-by-step, do this, then do this, then do this, then do this. That's not what we're doing. We're trying to avoid this, and we're trying to get the kids to actually think about what that actually means. Here we can see exactly what it means. We've got 213 5 times. Okay, so we've broken the numbers apart. It's pretty easy. So the next thing we want to do is now we want to establish some reasonableness. What makes sense for an answer? And I've seen a lot of kids do something like this, 213 times 5. And this is totally normal. It's a great learning opportunity. They'll do 3 times 5 is 15. They'll do 5 times 1 is 5. And they'll do 5 times 2 is 10. And there you go, 10,515. And I suppose, in a way, it makes absolute sense, right? But the problem is, it's not reasonable. Okay, so what I show the kids, and we've done a lot of work on rounding too, 213 is closer to 200 than it is 300. So let's round that to 200. We'll multiply it by 5. And knowing now that we've already multiplied by multiples of tens, hundreds, and thousands, now we can take this and we do 5 times 2, which is 10, but that's not a 2, it's a 200, so we'll make it 10 100 times bigger. We see 1,000. This is nowhere near it, so this can't be a reasonable answer. But 1065, 1065 is. So now we've established reasonableness. Now we're ready to get started with some of these problems, knowing that we do have a set number in mind that we want to get to. Okay, so now that we've built arrays and we have a good concept of this, the first thing that we're going to do is we're going to take a look at what is called, oh, I messed that up, the area model. Okay, now what this is a more efficient way than getting out all of these base 10 blocks, because if you could imagine we had 9,497 base 10 blocks, we're going to multiply that by 9. That is a lot of base 10 blocks, and that just sends shivers down my spine. I don't want to do that because you've got to be an efficient way. So we're going to use the area model, okay? So if we take a look at that very first problem that we started with again, that was 319 times 8. So let's take a look at it with the area model. So our area model here, what we're going to do is we're going to pretend like we've got all the base 10 blocks out, but instead I'm just going to make a very standard rectangle here. Okay, so it's 319, let's see, let's write this down, 319 times 8, okay? Let's break it apart, that's 300. All right, so there's that section. The 1 is 10, there's that part, and the 9 is 1. We have 9 ones, and all of these is being multiplied by 8, so we'll put that here. Okay, now it's like we've created an array, but instead of having all those base 10 blocks all over the place, we've got it nice, neat, and efficient. So we'll do 8 times 3 is 24, but it's not a 3, it's a 300, so we'll make it 10 100 times bigger. Now we've got 8 times 10, which is 80, and 8 times 9 is 72. We have our parts, and so we're going to rewrite this 2,400 plus 80 plus 72. Now that we've got it, we're going to add it all together. 0, 0, and 2 is 2. 8 plus 7 plus 0 is 15. 4 plus 1 is 5, and 2 is 2. And there we have our 2,552. All right, so that's our area model. The next step we're going to do is we're going to take this into what's called partial products. I mentioned that a couple minutes ago. All right, so we have our same number here. We'll use the same problem just so you can see that. We got 319 times 8. Now, if you think about all the learning that we've done a few things already. Remember over here we multiplied by multiples of 10 a while ago. I showed you guys that we broke numbers apart. We had the arrays. Now we made a more efficient model. But the thing that I don't like about this, or as far as from the sake of being efficient, is we can do this even more efficient yet. We've got this number written twice, we've got this number written twice, we've got this number written twice, and then we add them all up. What's great about partial products is you add it together. You only have to write it down once. So I'll start in the ones place here. We've got 9 times 8, which is 72. There's our first part. Next part is 8 times, now remember that's not a 1. We've done enough with expanded form and place value that we know that this is in the tens place. 8 times 10 is 80. And then next up we've got 8 times, not 3, but 300. And I know 8 times 300 is 2,400. Now we've written it down, not twice, here and here, but we've written it down once, right here. So we've broken them apart, now we just got to put them back together. And you're going to notice that the numbers we're adding here are the exact same numbers over here. It's just over here we've only had to write it once. We already know how to break numbers up using expanded form, but we're doing it all together here. So 2 plus 0 is 2. 7 plus 8 plus 0 is 5. So we got 5 tens. Regroup that 10 into 100. So we've got 400s plus 100 is 5. And then last up is our 2 for 2,552. So this is pretty efficient when you think all the way back to getting the base 10 blocks out, breaking it apart, building the arrays. And for different kids, you're going to have to spend different time with each of these. I think about it as a progression, with each of these levels of a progression. So let's think about this one more time. We've done the area model. We've gone to partial products. And now our next step here, this is the standard algorithm. Standard algorithm. Or what sometimes people call the traditional method. Right? But I'm going to use the word standard algorithm here. I think that fits the best. So let's think all the way back to the first problem that we did, the exact same thing. And what I want you to do now is I want you to look at how, when we traditionally have solved a problem, or at least how I learned or how I remember learning, and quite frankly, the method that works best for me if I'm not doing this mentally, This is what it is, all right? The problem with this is you're trying to keep way too much information in your head, that sometimes this method doesn't work best when you're doing it mentally, but with paper pencil I can be very accurate and very efficient with my time. So let's think about what we've done and think about how it connects to this same problem, all right? What's really great about this is you are adding these numbers and these numbers all while you're multiplying. All right, so for example, we're gonna multiply this out. We're gonna multiply our ones first, and we've got 8 times 9 is 72. Now, if you think about 72, that's 7 tens and 2 ones. We'll put our 2 ones right here. Now, I don't just write a 7 up here. I like to show the kids we're gonna add that 7. We added the 7 here. We added the 7 here. We added the 7 here. So let's just put that 7 right there in the tens place and we'll add it up. That way it's convenient, it's there, it's nice, it's neat, it's organized. We've multiplied the ones place. Now let's go over to the tens place. And we've got 8 times 10, which is 80, or 8 tens. Our 8 tens plus our 7 tens now equals 15 tens, or 150. So we're gonna add this up. We've got 5 tens that could go here, and we'll regroup that into 100. All right, now I'm gonna pause real quick and I wanna point something out. We've got 100 here, 52, 152. So 19 times 8 is 152. Over here, 72 plus 80, that's also 152. 80 plus 72, that's also 152. We're adding and multiplying this all together all at the same time for maximum efficiency. And I think that's why I remember this. It's the most efficient way we've got. So the last thing we need to do is we need to tally up those hundreds. So we'll go 8 times 3. 8 times 3 is 24. But these are hundreds, so we're thinking 24 hundreds. We'll add another 100, so that's 25 hundreds. And I'm gonna write 25 right here. We added 20, if you count this one, we've added 25 here. And we've added, if you count this one, 25 right there. Okay? You can tell the idea of efficiency just by the amount of ink that's on the paper. But the thing is, what I really want for students is I want them to be able to have a method that works for them, okay? I've had lots of kids that like all three. They're not impartial or partial to one. I have other people that will really like to draw out the area models because that's their go-to, that they find safety and security within this box. Other kids like the idea of being able to see everything drawn out and planned out. Some kids like to get their hands on some base 10 blocks just to make sure. Other kids are just after maximum efficiency. In 4th grade, what I try to do is I try to use all of them. And I try to use all of them all the time because I want all of the kids to see everything all the time as much as possible. And while I know that might seem like a bit of an overstatement, I think very similar to me, what I want them to do is I want them to find something that's accurate, but I also want them to find something efficient. And for my money's worth, I think this one's the most efficient, but you have to have an understanding of what's going on here, what's going on here, what's going on with the base 10 blocks. And in order to do that, you got to work all the way back to what we've been working on recently, is times 10, 100,000 times multiples of 10, 100,000. I suppose the last thing I didn't do, and I should probably always do this first, is I did not come up with an estimate, so let's do that real quick. I like to put a box right up here just so it's kind of like it's literally hanging over our heads. So 319 is close to 300. We'll multiply that by 8. So we've got 8 times 3 is 24. We'll make that 10 100 times bigger. So a good estimate would be about 2,400 or 2,400. And that's awfully close to 2,552. So there it is. That's just the standard algorithm, partial products, area model using arrays. And that's just for 2x1. I'll just get a little box here. That's by 2x1 digit, something like 19 times 6. And that's 3x1, which is 314 times 7 or something like that. And 4x1, which would be like 6,477 times 3, right? Problems like that. That's what we're gonna do. Now when we take a look at 2x2 digit numbers, something like 25 times 76, then we're gonna take some different approaches. They're gonna be very similar though. They'll see area model, they'll see partial products, they'll see and the standard algorithm. It just looks a little bit more complex. So please let me know if you have any questions. Go ahead and comment below, send me an email, reach out. I'm happy to help with whatever you want. But I want you to know again, my main purpose, and especially for showing you this, is not just to say, whoa, Mr. Bauer knows some crazy math. But what I want the kids to do is I want them to take them through the story of math. This, for me, is the ending. But here we see the middle of the story, the beginning of the story. There's this whole progression that we want to show. So thanks for viewing. Make sure to smash that like button if this helped out. But if not, yeah, let me know how I can help. And if you guys have any questions or comments, please make sure to get a hold of me. All right. Have a great day, and we'll see you in the next video.